Alright guys, welcome to this page of the notes, and again what we're doing is we're using composite functions to help us solve a problem. So let's take a look at what the problem is we're being asked to solve. We're told that Allmart is offering both an in-store rebate of $35 and they're taking a 15% discount on all MP3 players. This MP3 player normally costs $300. The question we're being asked to solve is this: which is a better price? To first do the discount and then take the rebate, or do the rebate and then get the discount, right? Which is going to be a lower price. So let's go ahead and solve this problem by first setting up our functions and then using composite functions to solve. The store is going to do two things. They're going to give you a discount, right? A percent off of the original price. Let's write our discount first. So d of x for discount. Now, the original price of the MP3 player is $300, but I'm going to use a variable instead, right? Because this could apply to any particular item that has a 15% discount. So the cost of the item, and then they're going to take a percentage off. Once again, if something costs $100 and it's 15% off, well, that means that they're taking $15 off the price of the $100 item. So what do you actually pay? You're only going to pay $85, right? Because you take 15% of 100, which is $15, and subtract that from the original price. So the original price of the item minus 0.15, 15% of whatever that price is, right? So again, if the original price was $100, well, 15% of 100 is $15. So 100 minus 15 is $85, and you would pay $85 for a $100 item that is 15% off, right? The next thing the store is going to do is give you a rebate, in-store rebate of $35. Now, again, in-store rebates are very, very rare. Hardly ever happens. Generally, when you get a rebate, it's what they call a mail-in rebate, which is how stores get around the problem we're about to solve. It is, well, actually, we'll get to that in a second. I don't want to spoil it for you. So here we go, the rebate. The rebate is $35 off the price of the item. Well, whatever the price of the item is, subtract $35 from it, and you have the price that you would actually pay. All right, what we want to do is figure out which is cheaper. Which is cheaper? Do I want to do d of r of x, which is to first take the rebate and then 15% off of that? Or do I want to take the 15% off and then take the rebate, right? Well, let's figure it out. Since I'm doing d of r of x, I need d of x first. d of x is x minus 0.15 times x. I'm then going to plug r of x into that. So that's going to be an r of x minus 0.15 times r of x. Plug in what r of x is. X minus 35 minus 0.15 times x minus 35. Again, what we're doing is first taking the rebate first, so we're subtracting the rebate from the original price, then doing 15% off of whatever's left, right? Well, the original price was $300, so plug that in for x. So we're going to do $300 minus $35, and then we're going to take off the discount. So then we'll take 15% of the 300 minus 35. Plug that into your calculator. Don't fat finger something on your calculator, and you get $261, and it comes out to like 2 cents or something like that. $261.02 is what you would pay. Right? This is the price of that MP3 player if you first take the $35 off of the 300, right? And then 15% off of what's left, right? So 300 minus 35 would be $265, and then you take 15% off of 265, right? And you get $261 and 2 cents would be the price that you would pay. Okay, then my other option make sure I can still see my equations, is going to be to do the discount, take the 15% off, and then apply the rebate. So here's the way that's going to work. I need R of X first, which is going to be X minus 35. And then I'm going to plug D of X into that. So R of D of X, which means I'm going to do D of X minus 35. Well, plug in what D of X is. D of X is X minus 0.15 times X minus the 35. So this is my D of X, that's my D of X, and then I have the negative 35, the rebate off of that. Okay, well, R of D of X, I know that my price is 300. So 300 minus 0.15 times 300 minus 35. Again, plug that into your calculator, slide it over so that we can see both prices here. And so what you wind up getting, if you put that into your calculator, don't fat finger something, the discount first, then the rebate, you get $220. $220. Okay, obviously, right? This is way cheaper. You take the discount and then get the rebate versus doing the rebate, getting the rebate, and then applying the discount, right? You want to, right? The cheaper way to do it is to apply the discount, the 15% off the original price, and then subtract the rebate from that. So here's our winner. The question we were trying to answer, right? Which provides the better price? Well, the one that provides the better price is going to be R of D of X. Taking the discount, then applying the rebate. Guys, thanks so much for joining me for this set of videos. Hopefully what you now are very comfortable doing is adding, subtracting, multiplying, and dividing functions, right? Just like what we did with polynomials. And then this idea of composite functions, which is putting a function inside of another function and doing, like I said, composite functions, being able to do it both for relations, for graphs, for tables, if I just give you functions, and then of course being able to use it to set up and solve a word problem. Guys, I really had a lot of fun doing this with you. I can't wait to see you next time. I'll see you guys later. Bye.